Hello everyone, glad to see you. Today I would like to talk about the circularity. As we can see, we are going to use this symbol for any rotating, let's say, shaft bearing. The component should have the circular cross section because we are going to control this circle, roundness of this cross section. In order to find the tolerance zone for this, we are going to have two coaxial circles perpendicular to that axis, and based on basic dimension, we are going to calculate what is the outer boundary and what is the value for inner boundary. Based in these two, we could see the profile of that cross section. In that situation, it is acceptable, let's say, cross section. We cannot use any datum feature or any modifiers. Let's see the advantage of the circularity. Here, let's compare this example. We don't have any circularity control form here, and we have very tight tolerance for the size. We can see by having this value plus minus 0.08, we are going to control the cross section. It should be in this interval, 0.16. But here, we have much wider tolerance zone for the size, and by implementing this, let's say, circularity, we are going to control the shape of this cross section. We can have the same circularity or roundness for both of them, but here we have much wider tolerance zone for the size. This is the advantage of implementing circularity symbol. As it is mentioned here, the form tolerance zone should be smaller than the size tolerance zone. Here I am going to compare the circularity and straightness. If we look at this shaft from this view, we can see the shape of that in this view is circle. By using the circularity control, we are going to control this shape. We are going to control the roundness. But if we are going to look at this shaft from this view and implementing a straightness, we are going to control this line. Conceptually, they are the same, but in different view, we are going to control different profiles. Here, we are going to control a straightness, as we can see. In another view, we are going to control the circularity, the roundness. In order to measure the circularity, we have this indicator here. We are going to rotate the component, and we can see what is the roundness for this cross section, the top. And then we come down, and then for another cross section individually, we are going to control the roundness, as we can see here. In the last slide, I would like to highlight we can implement this circularity for any component whenever the cross section is circular. For example, for cone, for SPF, for pipe, because we know what is the value of basic dimension for that cross section, and then we are going to make two coaxial circles, and then we can calculate what is the outer boundary, what is the inner boundary, and then we can see what is the acceptable zone for the circularity, and the profile of that cross section should be in that interval. For now, I would like to close this session. In coming session, I'm going to talk about cylindricity. Thank you for today. I hope you enjoy it. See you next time.